Hi, this is Terry Iverson from CNC Rocks Manufacturing Camp. I'm here to talk about, today we're going to talk about processing, and just through some basic turning components or turn components. So you have a little bit of idea when you sit down to process a part what that entails. So this is a piece of brass bar stock. Brass is always a good starting point because it's very free machining. The parts that we machine on the videos are in brass, and it's you can run without coolant. Your tools don't get so hot, don't wear prematurely, and so brass is very free machining. So we'll start with the coolant ball that we ran and that you'll see or have seen in the video. And so if you look, you can see that my OD, outer diameter, of the bar stock is well within the actual part that we're making, if you can see it. So first and foremost, when you're running bar stock, you can either have slugs, or you can actually have a bar where you're going to feed the bar and you're going to cut it off. On machine tools, on lathes, I think I've said this earlier, but and I'll say it again, is that when you have a bar and when you feed the bar, it's held in something called a bar feed. When you cut off a part, it's caught, the part is caught by something called a part catcher. So there's a lot of very literal terms that I'll allude to that are almost self-explanatory, but maybe not. When the chips go down into the pan, there's a conveyor that takes them out. That, of course, is, yep, you guessed it, chip conveyor. So basically, when you start to make a part, in this part specifically, you'll feed the bar out, and then what you'll do in this particular case is you'll center drill. A center drill operation, and you'll see this in the video, or maybe you've already seen it. The center drill makes sure that the drill following it doesn't walk or doesn't go off center. Of course, if a drill goes off center, your ID, your hole, is going to be oblong, or you're going to break your drill, one of the two. So consequently, after you center drill, then you come in, you change tools. On a gang style machine, you'll move over, and then you'll drill. We have some really good video of the brass in slow motion where you can actually see the chip being generated in slow motion, which I think is pretty intriguing. It really gives you a chance to understand how the metal is removed. After you center drill and after you drill, then in this particular case, this part has a thread in it. If it's an ID thread, you're going to tap it. If it's an OD thread, you're going to single point thread it. Single point turning prior to it and single point threading on an OD. There are die heads. Die heads will allow you to thread on the OD. They're usually called geometric or self-releasing, but we'll talk about that later. So in this particular case, in this part, back to the coolant ball, after we center drill and drill it, then we're going to tap it, and then if you look on the video, then we're going to start the turning operation. And in the turning operation, what we're going to do is we're going to face the part, the end of the part, and then we're going to contour a radius, then the straight OD, and then we move over to the back side and we plunge for clearance, and then we back turn the radius on the other side. So you'll see that in the video. Then when we're done with the contour, then we'll come in with the cutoff tool. In this particular case, the cutoff tool is on the other side, and then we'll plunge in and cut off the part, and then it'll fall down into the parts catcher. So that's a little bit of a description of the coolant ball that we made. What I'd like to do is talk a little bit about a couple other parts. Once again, we're going to stay on brass. So we're going to go back to our bar stock again. And these are some small salt and pepper shakers that my dad, when he first got started in the business, I think he made it in a tech school that back in the 60s. That's how long these have been around. But you can see it's about the same diameter. So if you look, you can actually see the bar diameter and the actual major OD, right, outer diameter. In this particular part, back then, this probably wasn't made on a CNC. CNC probably at that point wasn't even invented yet. Back in the 60s, well, I know it wasn't invented. So in this particular case, you're going to face off the end with the turning tool. You can do the ID first or you can do the OD first, whichever, but in this case I'm going to do the ID first. Then you come in with the center drill on center. You center drill the face of the part, once again, so you're a good starting point for your drill. Then you're going to come in with your drill and then actually drill the ID, inner diameter. And if you look down in the bottom of this part, you can see the angle where the front angle, lead angle of the drill is formed in the bottom. Then after you do that, then you may come in and bore. I doubt if this was actually bored, but it might be. It might have been bored. As I look at it, it probably has been bored. So you come in with a boring tool. So the boring tool will have an edge off center from the center line of the bar, and then you'll bore out the ID, inner diameter. So then back to the OD, we're going to take a turning tool, and we're probably going to probably use a grooving tool first, just like we did the turning with a grooving tool on the coolant ball. So we'll probably plunge down into the stem of this salt and pepper shaker, and then we'll probably back turn. Once again, this is a CNC process, not a manual process. And then you'll back turn, and then you'll come in and then profile the base of this so that it all blends in. And that's where you can get into some tricky geometry in programming. So there's CAN cycles. CAN cycles in programming is basically just like it sounds. It's a CAN G-code, it's a CAN G-code setting and program that you plug in numbers and then it does the operation with very little information. So CAN cycles are wonderful in programming. So in this particular case, the last thing we would do if this was a bar operation is we would cut this off. So that is the base of the salt and pepper shaker. Now on the other side of the coin, so to speak, there's a aluminum, now we've changed materials, an aluminum cap. And you can see on this that this one has S for salt, and then this one here has P for pepper. So in this particular case, one's a little bit duller than the other, but in this particular case, you'll probably do two operations. In this particular case, you'll face off the end of the bar stock. You'll go in with a drill, and center drill once again, and then a drill. And this particular case, down in here in the lower portion of the inner diameter ID, you can see that it's probably just drilled, not bored. But here where the thread is, where you thread onto the OD thread, actually, let me go back. I didn't talk about the thread, pardon me on that. You would have to, on this particular part, do a counter turn somewhere in the turning operation, and then you would have to single point thread this, okay? So you could do a geometric die head, which I mentioned earlier on the OD, but as I'm talking about the cap, and I start looking at the thread, I realize I didn't tell you about putting a thread on the OD, on the mating part. So you would bore the ID to prepare your inner diameter for the threading operation, and in this particular case you would come in with a tap, or potentially you could do a single point ID thread as well. So that, having said that, then at that point you would probably cut it off and it would be a straight, you'd want to make sure you turn the OD, and then you would cut it off so that you could turn it around. And once you turn it around, on a CNC, you're going to want to hold it on the OD or the ID, but you got a thread to be concerned about on the ID. So you're going to hold it on the OD that you turn, so there's not a lot there. And then you want to face it and then contour this radius so it's nice and smooth. So that would be your secondary operation. You could hold it on the ID, which you could then contour the radius again, and then you could clean up this OD if you didn't clean it up on the previous operation. So that being said, now you've got a completed turn part, but now you have to put the S in. Now that would be a little tricky manually. You could probably use a drill press and draw the S, and then move your part underneath the drill press and then just come down and drill along the line. But on a CNC machine, you would have your drill in the spindle, and then you could actually program your position of your drill in an S type of configuration, or in the pepper in a P configuration. So CNC has made things so much easier. Back in my dad's generation and my grandfather, you know, the tool makers had to do all this manually, or they had to go through lengthy procedures to get some of the geometric or geometry. For example, this particular radius and this plunge on the base of the salt and pepper shaker, that might have had to been a form tool. So you would come in and plunge that and catch all that radius, that angle, and that stem all in one tool. Well, that means a tool and die maker has to make that form tool. And so making that form tool can be a whole task in itself by a very complex process. So the last part I'll talk about, once again, I'm going to go back to my bar stock so you can actually see this is like a barb, almost like a fitting of sort. And we use this on the inspection system as a demonstration part for inspection, digital inspection system, which there's a segment you may have seen on that, or you'll see later. But you can see it's about the same diameter again. And so on this particular case, you're going to have, once again, we're going to start, and we're going to actually start this part this way out. So we're going to face the part, have a turning tool. I'm going to do turning first on this one. And I'm going to turn this radius, come up the face and turn the diameter. And then what I'll probably do is pre-turn the back diameter here and then change into some sort of a grooving tool that has this geometry in it. I could single point that, but it's probably easier to have this contour, this angle into a plunge on a grooving operation. So then I come along and after this diameter is caught, then this actual barb is consistent, so I would just plunge, come up, plunge, back up, move over, plunge, and so forth. And then I would then go back to the turning tool. Hopefully maybe I've already pre-turned this. And now what I've got is I've got the ID operation to do. Let me back up and say that ID, the advantage of doing the ID first is that I'm not going to put any stress on the part when they get down to where I don't have much of a web. And so it's probably best to do some of the turning first and then maybe leave this so that there's a little bit of strength to it before I drill it, or I can drill the part first. There's a number of different ways to process a part, and you may not know what the right or wrong way is until you get there, and then you realize, okay, I have to reprocess the part. So that means you may have to cut and paste part of your program, and in the programming, we usually have each operation with an N command. So then you can take, N10 and move it down to N40 or N20 and move it down or up to N10 or what have you. So back to the ID, you'll want to center drill it, then you'll want to drill this, and there really isn't any, doesn't look like it's been bored, but you could bore it. And then you'll come out, go back to a cutoff tool, and then you'll part off the part, cut off the part, and of course that will fall into, yep, you guessed it, a parts catcher. So that's a little bit of some brass parts, the part that you'll see machined on video, and also a couple parts out of similar size diameter brass. And we'll move on to more processing with more difficult parts, but this is a good starting point, is talking about small brass components.